welcome to the webinar. This is about the light pipe design guide and everything you need to know and a little bit more. I want to say welcome. So I'm Sana Dinding. I'm the Director of Product Development and Marketing at VCC. And today I have Carlos Ramirez with me as well. He's the Electrical Design Engineer and Supervisor at VCC. He has a really broad experience with the electrical and the mechanical, and also how to design light pipes. So that's all the knowledge. That's what we want to share with you guys today. You can see the agenda out here. So we're going to talk a little bit about VCC, and then Carlos is going to go deeper into what's a light pipe, how does it work, the LED is a light pipe, or light input, the common problems, how light is going to exit within a light pipe, and then also a little bit about design and manufacturing. We will have Q&A in the end. I'm sure everybody knows a little bit about how Zoom works. So I will please mute yourself if you haven't done it yet, except for Carlos and me. And then you can use the little chat. And then when we at the end, we'll go through, any questions that's right there. So let's get started. A little bit about VCC. So we are the expert when you talk about HMI solutions. We are a recognized leader within the illuminated electronic market. We were founded in '76, so we have a lot of experience. And then we opened our assembly operation in Mexico in '96. So we are proud of having nearshore manufacturing. A lot of stuff that happened over the last couple of years. You can see we did a lot of acquisitions from 2012 to 17, also back in 18. And that's where you can see how our portfolio has expanded. We're also really proud of all the awards we've been winning. We won one in 18 and in 19, and you can go to the website, of course, and look into more. The latest and greatest is that we have been expanding our SMT production line. We started that last year, and now we actually expanded to having 3 lines. So, more to come, but we're excited about that. And going into a little bit more detail here, so we are the experts when we're talking about HMI components. Some of the categories I want to highlight here is that we have Panama indicators and light pipes, and also LEDs and LED display. But go to the website and explore more if you're not familiar with VCC's product. We also have many value-added services, and that's why you're here today as well, right? So you can learn more about the light pipe. Either you want to be educated or you want to see what VCC can offer. But we also have value-added service that is the PCB production, also custom wire harness. But let's jump in, and I will give the microphone to Carlos.
Hi, how are you? My name is Carlos Ramirez, as Sana mentioned, and I'm the supervisor of design engineering here at VCC, which I've been here like 5 years now. So I'm gonna talk about right now what is a light pipe and how do you design it and common problems that you encounter when you're trying to design them. So this is just a slide that we normally start with, and the reason I use it is because back when I didn't know about nothing about light pipes, when somebody told me about a light pipe, the first thing that came into my mind was a lightsaber from a Star Wars. But let's just get into the details here. So light pipe, they have a lot of different names in the industry. They call it light pipe, light guide, light tube, but at the end they're all the same thing. And it's basically a method of transporting a light from one end to another, from point A, B, or from the source to the target. And the goal is always to have 100% light transmission. That's the goal, right? Even though in reality, it's as we will see in a minute, it's not achievable in real life. As I mentioned, has an input surface and has an output. In this training, we're gonna call it target surface. And target is basically what the end user is gonna see. That's the target surface. This is just a little bit of examples of what we, different light pipes, light guides, and the reason they're really important is because almost all, if not all, the electronic devices out there, they have some sort of a human to machine interface. It could be a LED most of the time, and in order to make it more appealing to the end user, they design, or people design, light pipes so it looks nicer. So there's just some examples. Some of them are like good examples, you know, like a good design light pipe, such as this one. This is one that I think it's not a really good design light pipe, but it's just to give an idea of the usage of the light pipe. In the light pipe arena, there is two types of light pipes. You know, one is the rigid light pipe, and it's basically a molded part. And these are mostly used when you upfront know, mechanically speaking, where is your input and where is your target, in reference to the whole assembly. Because they're easy to use, they're easy to assemble, and they're small. They're cost prohibitive. But, and again, you need to know in advance a lot of the mechanical constraints up front. The other ones that we have is what we call a flexible light pipe. These are really good, or these are mostly commonly used when the input and the output, they're like either far away, or there's some obstacles in between, or there's like a weird shapes that the light, or between the input and the output. And I mean, they're like a little bit more expensive, but you know, they do the job, and they work exactly the same. Now we're going to talk about a little bit more into the detail of the light pipe and the physical attributes. As we're mentioning, we have an input side in which, you know, normally we have a LED. It could be, you know, different types of LED. It could be SMT, through hole, or a combination of both. We have the actual geometry of the light pipe, which has to have certain characteristics that we're going to talk about later. And then we have the output, or a target surface, which they will have to have different surface characteristics as the body of the LED in order for the light to be expulsed off of the light pipe. And I'm going to explain a little bit of the detail. Now, this geometry can have any shape, form, arbitrary. It will be the engineering job to make sure that, as we mentioned before, most of the light expulsed from this LED ends up on the target surface, and in a way that it's aesthetically pleasing. So let's just go a little bit into the detail of how the light pipe work. And to do so, we're going to talk a little bit about the physics of light, just a little bit. We're not going to get into a lot of details, but one of the important characteristics of light is what we call the refraction, hence the refractive index. And this is the characteristic of the light that makes the light ray to when it goes from one media to another, to change the angle of the light ray. For example, on vacuum, it's 1, so that means that there is no refraction. Air, water, acrylic. So what we're trying to say here is this attribute is really important for the light pipe to work, and I'm going to explain to you a little bit why on the next slide. This is just a little is more a picture that tells a little bit more in detail what this angle of refraction looks like when it enters the acrylic. Enters with this angle and then travels with this other angle inside, and then when God gets out, it's with another angle. And why is important this? Because for the light to travel inside a media or a light pipe, we need to make sure that we use this critical angle for total internal reflection. Just to give an idea, for polycarbonate, the angle is 39, and for acrylic is 42. What does it mean? Okay, if you have a light pipe made out of polycarbonate, the angle, any light that hits this surface, an angle of 39 or less, it will bounce back. It will bounce back inside the media, and that's particularly the thing that makes the light go from one end to the other. So when you're designing a light pipe, it's really important that you know what is the total internal refraction angle for that particular material. Because if you don't, if the angle doesn't meet this, or is, you know, it's not what it's, at least this minimum, the light is gonna go outside. And I'm gonna explain to you a little bit more, you know, when we on the next slides. And this is just a little bit of a terminology that explains that there's always a loss between, you know, when the light goes from one media to another, and this is totally normal. So when I was telling you that the goal is to have 100% output from it's gonna be impossible. There's gonna be always a loss. One of the important characteristics for the light pipe to work is not, I mean, it's the light pipe itself, but it's also the LED or the light source that you're gonna use. And the reason is pretty simple. The most important ones are the viewing angle and the MCD, which is basically MCD is the light output intensity. And I'm gonna give you why it's important. All the LEDs, all of them, they have characteristics of their data sheet, and these two are all just two of them. The viewing angle represents the light distribution in reference to the you know, center. For this particular one, we are talking about maybe 160 degrees, you know, from one end to another. They're depending on the LED, on the light pipe application, is the amount of angle that you're gonna need. Let's just say, for example, if your light pipe is narrow, you know, it's narrow here, then you wanna have a narrow angle or narrow beam LED. And the reason is because the goal is to funnel as much light as possible to the input of the light pipe. If you have a wide angle LED, then there's a lot of light that is gonna go on the side, and it's not gonna go funnel into the light pipe. Another characteristic important is the MCD. If the light input it's really dim, then you know you can have a narrow angle, but if it's not enough light coming in, not because of the angle but because of the LED intensity, your light output at the target is gonna be dim. So depending on your application, this is what is important to, you know, take a look at in your consideration. Sometimes you need to do like a, you know, you need to get like a really high MCD LED to be able to have a decent light output at the target surface because of the different geometry on the LED. And you know, it's okay, but it's just something that you take into consideration. And these other two considerations are important, but mostly because of the electrical design, the power consumption. You know, LEDs, they have different power consumptions depending on the light output, and that's something that you need to take care in consideration as well, depending on if your device is battery powered or you're gonna have a, you know, 100% all the time electrical energy on it. And this is mostly important when you're doing manufacturing, right? Because SMD are, you know, LEDs are a whole lot more easier to install than leaded LEDs. But, you know, these are normally wider angle than these ones. So there are some things that you need to compare between these two, not just from the manufacturing perspective, but also from the characteristics perspective. So we're gonna talk about a little bit now on by looking at the problems on the light pipes is how I'm gonna address the how you can design them. So, and the whole system. As I was telling you before, one of the common problems that we have is light loss. So light loss can come from the gap between the light pipe entrance and the LED that is not properly set, and also the narrow or the beam angle of the LED, or a combination of both. So this is pretty evident that if the gap is wider, or if the LED beam is wider, there's gonna be a lot of light going outside the light pipe, and there's only just a few light rays going inside, and that would create a dim effect on the target surface. Whereas when you use a smaller gap and the proper beam LED, then most of the light rays are gonna travel inside the light pipe. Therefore, you're gonna have a lot of light rays on the target surface. This is what we call flux coupling. Again, this is just to reiterate this information that I was just telling you, that the flux coupling is important. It could be the beam angle or the distance. Yeah, this is just a few more slides showing the same concept. This is part of what we're talking about on the total internal reflection, and this slide is pretty important. When we are discussing straight light pipes, the TIR is not really important concept, because the light is not gonna try to bounce in any other angle or a direction, except straight, from the surface, from the target to the surface. But when we start adding weird shapes, this is just like like a regular right angle. This is when it gets tricky. And the reason is because this is what we call the TIR, or total internal reflection. Most people, they think that the light, it's kind of like the electricity, and it just, as long as you have a path, it will follow. This is not true for light. The light is just gonna try to follow. Wants to go straight. So let's just pretend that you have this as a right angle here. What's gonna happen is this light, instead of bouncing this way, is gonna go this way. What is gonna happen? You're gonna have a lot of light on this area, and probably it's not your target area. It's gonna be inside the housing, and here is gonna be really dim. That's why you need to add this angle. And this angle has to do with the total internal reflection angle that I was telling you before, and it's depending on the type of material that you're gonna use. So you need to play with this angle to guide the light towards where you want it to be. Still, you're gonna have some light here that is gonna escape, but it's gonna be minimal, because again, you're gonna guide it through this side. The shape is not. It's really important, but as you can see with this other example, it could have have a radius, or it could be straight, as long as this total internal reflection angle characteristic is met. Now, other problems that we encounter when we design light pipes, and is when we have what we call hotspots or dark corners. And it appears mostly when your target surface is a wide area. When it's a small area, it doesn't really, it's not apparent, because all you're looking at is a dot. But let's just pretend that you have a wider area, and then if your light pipe is not designed correctly, you're gonna see some areas that appear to be darker or brighter, depending on how you see it. And this is a problem that is really common when you're designing, again, like wide area light pipes, And you know, one of the goals is to have a even surface, or the surface to look even when it's on. Let me see. Go back. Sorry about that. When you're to do this type of to fix this type of problem, you need to take in consideration the amount of LEDs that you're gonna use on the surface, because probably one is not gonna cut it. You need to put several ones located in a special pattern to be able to get this area to light up evenly. You also probably need to take in consideration the distance between the light output and the target surface, because if it's too close, then you're gonna see more hotspot than when you have certain distance. And also the material that you're gonna use as a target, you may probably need to add some diffusion, you know, the diffusion agents to help on that process. This is showing that the target surface has to have some special surface that would, by changing it, the light rays are gonna hit at, you know, different angle than this surface, and they're gonna try to escape, and that's what you want. But this surface is also important because it will give the appearance of a smoothness of the light. If it's not done correctly, even in this small surface, you're gonna start seeing some hot spots. There's a type of material, could be glass, could be plastic, that help the light to get diffused. So that's something that we can, you know, if it's needed, you can add in between the light input to the target surface to make this light look more even on the target surface. There's also different type of textures or finishing or a surface on the light pipes that will help distribute the light better. This is just a plain textured surface. This one, see, has a Fresnel surface that would make the light look, or the surface to look better at a wider angle, you know, in reference to the end user. It may appear to be complicated to design a light pipe, and you know, believe me, it is complicated, and that's the reason why this special software, 3D software, exists, because they simulate how the light rays are going to travel from one end to another. And that's something that we have in VCC. So basically, if you have a light pipe that it's complicated, you know, we can help you design it using this software. This is just a few examples of products that we have designed. You know, this is how they look on the simulator, and this is how it looks on the real life. This particular example, you know, is the customer came to us with a problem saying that in this surface they have a hot spots. And you know, indeed, when we did the analysis as is, we saw this light pipe hotspots here. So after we did some analysis and some modification of the geometry, we end up having a better light output smoothness. But you know, still you can see a little bit of hot spots. But at this point, that was the most we could do. This other example shows that, as I mentioned before, the geometry of the light pipe is not really important as long as the TIR angle for that particular material is met, in order to guide the light rays from one point to another. This is just an example of some of the devices that, some of them we have designed, some of them we just have example from the web, but this is just to give you an idea of what we consider a good design light pipe. In this case, this is a good design of a light pipe. As you can see, there is no hot spots. These, of course, the Apple from the MacBooks are pretty neat. But look at these guys. You can see totally the hotspots here. So, I mean, if that's your design intent, okay. But in our experience, this is a bad design. You want the light pipe, the smooth to be, the surface to be smooth, such as this one, right? You can see that the light ring is perfectly even all around, and this is something that can only be achieved by trial and error, or do a light simulation. Now we're talking about when we design something. Of course, we don't go straight to a manufacturing of the mold. We first do prototyping. In the case of BCC, we use a 3D printed SLAs, or if it's not possible to do so, we use CNC machine. And in both cases, it's really important, not just the machining or the printing, but it's as important the polishing, because as I mentioned before, the surface of the light pipe, it's really important, really important. If it's not the correct surface, the light is going to try to escape from a surface that it's not the target. And by the same token, it's extremely important also the molding consideration, because this is, the light pipe is not like your normal plastic part that can have a parting lines or bubbles or a flood or cosmetic imperfections along the body of the part. The light pipe cannot have those, because, and sorry to be too repetitive, any imperfection of the inside the light pipe or on the surface of a light pipe which is not the target will cause the light pipe to escape because of the TIR that I was telling you about. And that's why when you design a light pipe, it's important that you know where your knit lines are, where your parting lines are, where your expulsor pins are, and definitely it is very important what finish you're gonna give to certain faces or areas. And in some of or most of the other plastic parts is not important, but here you need to have like a really almost mirror finish in almost all of the areas, again, except on the target surface, and that will have the surface dependent on what you design to be the optical optimal to have a nice and even light output. As I mentioned also before, the plastic is really important when you're designing the light pipe, but it's also important when you're considering all other characteristics that will be particular for your end product, such as that UV flammability, to UL 94 flammability rating, UV resistance, and some other consideration as which one is more abrasive to the tool. That will be depending on how many shots you want to get from a particular mold. But there's tons of different type of optical clear material, but for the most part we use acrylic or polycarbonate, different grades. But again, you need to take in consideration other characteristics as I mentioned before, which is the UV resistance, the 94 UL flammability rating, and of course it's not here, but one of the things that I want to mention too is some of these materials, they have certain degrees of how do you say it? Some of them they have an option not being totally translucent. They have certain material that they add, so they look like milky white, or they have certain that will help to add to help the target surface to be more even. Some of them they have the capability of adding material inside, some crystals that we call bulk scatter. This bulk scatter is some crystals that would help the light to bounce more inside the light pipe, and the goal is to have a more even surface on the output. That's what you gain, but then you lose on the light, on the amount of light output. There's a lot of, not a lot, but there's some loss of light along the way. So if you don't have that bulk scatter, you're gonna have more light output, but maybe not as even on the surface. But if you add bulk scatter material, it's gonna be less output, in terms of light intensity, but it's gonna be more even on the surface. So this material, some work better with certain plastics. Some of them, depending on the grades, they don't accept this type of bulk scatter. But then again, this will come as part of the design itself. Once you do the analysis, you can add this type of material into the equation on the simulation, such as that when you're actually doing the part, it'll look almost the same, in the real life as is in the simulation. I guess this is it. This is I don't know if I went just too quick, but if there's any questions, I'll be glad to answer. And if I don't have the answer right now, you can provide your email or your phone number, and I can definitely touch base with you later time.
Yeah, thank you so much. And if you go to the next slide, Carlos. There. Also, if you want to have some more information, you can also go on the website. Of course, email us if you have any questions. But some of the information that Carlos went over is on the website. We have a light pipe design guide. We have capabilities. There's FAQ, custom solutions. So there's more to learn if you want to do that. I don't see any questions right now. So thank you so much for attending the webinar. We hope that you learned a lot. And thank you to Carlos I'm learning every time. Okay, have a really good Thursday and see you soon again to a new webinar.
Thank you.